Question number 3 on trigonometric ratios and angles. Draw 4 possible diagrams for a related acute angle of 60 degrees. Find tangent of each principal angle and describe and state general rule based on your findings. So this question will help you to understand how acute angles and principal angles are related and about an important rule which you learn. I'd like you to pause the video, copy the question, solve it, and then look into my solution. Here is my solution. So in this particular question, we need to draw 4 possible diagrams for a related acute angle of 60 degrees. So let me make 4 coordinate axes here, right? So 1, 2, 3, and this is the 4th one. So we are interested in drawing related acute angle of 60 degrees. So related acute angle is always measured with horizontal, right? And it is acute, it means it is between 0 and 90 degrees. So 60 degrees could be in either of those 4 quadrants, and that is why we get 4 different angles or 4 different positions for our angle to represent acute angle of 60 degrees. Now this is the one in quadrant number 1. Let's say this angle is 60 degrees, correct? So that could be 1. Here it could be like this, right? 60 degrees. In this case it could be like this, and in this case it could be like this, right? So these are 4 positions of principal arm which will have related acute angle of 60 degrees. So what we're trying to say here is that this angle for us is 60 degrees. That means from here to here it is 60 degrees, right? That is 60 degrees. From here to here it is 60 degrees. And in this case it is this one which we are calling 60 degrees, right? We also call this as reference angle. So acute angle, related acute angle, or reference angle. These are the different names with which the same thing is being referred to, correct? Now as you can see here, these 4 positions are in 4 different quadrants. This is quadrant number 1, this is in quadrant number 2, this one is in quadrant number 3, and that one is in quadrant number 4, right? So these are in 4 different quadrants, but the related acute angle for all of them is 60 degrees, right? Now let's move on to the next part of the questions. We have already answered the first one, which is drawing 4 of them, right? And then now we'll do the next part of it, which is find tangent of each principal angle and describe and state general rule based on your findings, right? So let me first write down what the principal angle is in this case, right? So we'll write theta p as the principal angle. So we say theta p is equals to, in this case, that's the terminal arm. So it is exactly same as the related acute angle. It is 60 degrees. Now here, what is theta p? The principal angle, theta p, is actually the angle from here. It is always measured from the initial arm, which is along the positive x-axis, correct? So this is positive x-axis, and that is the y-axis. So if you see that, it should be 180 minus 60. So that gives us how much? 120 degrees, right? Now in these 2 cases, it should be 180 plus, right? It is more than. So in this case, theta p is equals to 180 plus 60, correct? So that gives us 240 degrees. And here, it is 360 minus 60 degrees. So theta p in this particular case is 360 minus 60. That gives us 300 degrees, right? So I hope you understand how we got the principal angle. Now let's talk about finding tangent, right? To find tangent, what should we do? Well, one thing you should remember is you can use a calculator, for example. This is one thing which you can do, right? Second thing which you can do is use your reference triangle, right? So I will use my reference triangles to answer this question, right? So here, let me make a 60 degrees triangle for you. 60 degrees triangle will look like this. So let me draw a perpendicular from here in a different ink. So that's clear what we are talking about. So that is a perpendicular, and this triangle is 60 degrees triangle for us, correct? Now here, let us say the triangle has sides of 2 units. Then when it divides with the help of this perpendicular, each side will be 1. So this is 1 and 1, that makes this 2. Equilateral triangle, as you know, should have equal sides. The perpendicular will be 2 square minus 1 square, that means 4 minus 1 square root. So it will be square root of 3, right? Now this angle is 60 degrees which we are talking about. So that is the angle which is related acute angle which we are talking about. So when we say tan of 60 degrees, right? So let me write down here tan of 60 degrees. Then what are we trying to find out? We are trying to find the ratio of opposite over adjacent side, which is square root 3, right? So which is square root 3. Now in this quadrant, you can see x is positive and y is positive. Both are positive. Therefore, the value is positive square root 3. Now let's consider now in quadrant 2. In quadrant 2, if I drop a perpendicular like this, you can see opposite side is positive. That means y value is positive. So let me also write one more thing here. Let's take a point here, right? So let me take this point and write it in a different ink. Let's say this point for us is xy, right? Then in that case, what is tan theta? So what is tan theta when the point is xy? So tan theta is ratio of y over x, correct? So let me write here. Or we'll write here. What is tan theta? Tan theta is equals to ratio of y over x. Y over x. For any point P which is xy. So we'll remember that part. So that will help us to explain all the positions, right? In this case, as you can see, x coordinate is negative and y is positive. So if you take a ratio in which one of them is negative, in that case you expect a negative answer, correct? And therefore tan is going to be negative in this particular case. So we can say tan of 120 degrees, which gives you the same related acute angle. So we are considering the triangle which is this triangle. Is it okay? Now here, as you can see, this side will be square root 3, positive, and this will be 1, negative, since this is in negative x direction, right? And therefore this is going to be negative square root 3. Now if we come to this quadrant 3, in this case again, if I drop a perpendicular here, my x value is negative 1, right? This is negative 1, and this value is negative square root 3. Now if I take ratio of these two, what do I get? I get positive, right? So we say tan of 240 degrees should be equals to square root 3 negative divided by negative 1, which gives me positive square root 3, right? Now here, in this case, we have x is positive, it's along positive axis, but y value is negative. So tan of 300 degrees is equals to negative of square root 3, right? Since tan is a ratio of y coordinate over x coordinate. Y coordinate has a negative value in this case, correct? So that is how you get similar value of tan. In two places it is positive and in two quadrants it is negative. That reminds you of what rule? It reminds you of cast rule, right? So it is the cast rule which we are considering in all these cases. So cast rule is that cosine is positive in quadrant 4, all are positive in quadrant 1, sine is positive in quadrant 2, and tan is positive in quadrant 3. So you see tan is positive in these two quadrants, correct? So that means positive here and positive in this quadrant, right? So these two quadrants, tan is positive and it's negative in the other two quadrants. So this reminds you of the cast rule. So that is the general rule which we can explain our findings are based on, right? So that is one way of saying it. Second is tan is ratio of y coordinate value over x coordinate value. And as we move from quadrant 1 to 2 to 3 to 4, the values of x and y changes. X is negative in quadrant 2 and 3, y is negative in quadrant 3 and 4, right? Therefore, now since x and y have different signs, in quadrant 2 and 4, tan value is negative. Since x and y have same signs, in quadrant 1 and 3, it has positive values. That could be another rule which could help you explain why tan itself has positive values in quadrant 1 and 3 but negative in 2 and 4. Correct? So that is how you can explain actually two rules here. Okay? But basically we are asking for cast rule when we say describe state general rule based on your findings. So we say the cast rule tells us that all are positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cosine is positive in quadrant 4. Okay, so that's how we can explain these things. I hope that's absolutely clear to you. Thank you.